Hi guys, this is Jonathan Lambert of the Mathematics Development and Support Service at the National College of Ireland, and in this short video, another video in our series of videos dealing with probability theory, is going to look at another example of the application of Bayes' theorem, but in this case in relation to calculating the probability of a particular algorithm detecting whether an email that has been sent through is spam or not spam. Okay, so let's assume that we've developed a new algorithm, okay, for detecting spam emails, okay, spam emails, okay, and we want to know what's the likelihood that a particular email, okay, will be flagged as spam, okay, if that makes sense. So what we know is this. Well, we're going to use Bayes' theorem for this. Yeah, okay, now don't forget Bayes' theorem says this is that the probability of a particular hypothesis, okay, given the observed data, is the same as the probability of the data, assuming the hypothesis is true, times the probability of the hypothesis divided by the probability of the observed data. Okay. So we're going to change these things around a little bit, okay? So let's just assume that the frequency, let's say, of receiving spam email, let's say the frequency is usually about 3% of emails that are coming in are spam emails. So let's assume the following, okay? Let's assume the following, that the prevalence of spam emails, the probability of getting a spam email is, let's say, 0.03. So 3 emails out of 100 will be really spam emails, if that makes sense. Let's just assume that, okay? And let's also assume that we've actually ran our algorithm, okay? So this particular algorithm for detecting spam emails, and what we've done is we've fed into this algorithm actual spam emails, and our algorithm gave us let's say we fed in 100 spam emails into this particular algorithm, and what it told us was that out of the 100, that 90 of the 100 were actually spam. Okay, so it has this let's say positive hit rate, and also this negative hit rate, if that makes sense. So what we also know is this, is that the probability of getting a positive result when we actually give the algorithm spam email is 0.90. In other words, if I give it a spam email, a real spam email, it'll tell me it's spam 90% of the time. Okay. And also, let's assume that when we were actually when we were testing this particular algorithm, not only did we give a spam email, we also gave an email that wasn't spam. And we wanted to see how well it fared in relation to, did it say that this email that wasn't spam, did it say that it was actually spam? And what we know is that 2 emails out of 100, even though they weren't spam emails, were classified as being spam. So the probability of a positive result, giving that the emails were not spam, okay, was actually equal to 0.02. Okay, and that's all the information that's been provided. Okay. Now, what we're really interested in is we're really interested in not about getting a positive hit, but actually about the probability of actually classifying something as spam or not. So the probability we're interested in is, what's the probability, okay, that an email, okay, that if we get a positive result, so if we get a positive result, okay, that the email is actually spam. That's what we're interested in. What's the probability that, given that we found a positive result, that the actual email is really spam? Well, from Bayes' theorem, okay, spam being the hypothesis, positive being the data, okay, we end up with, well, here's the rule. It'll be the probability that we get a positive result, knowing that we gave it a spam email, times the probability of a spam email, okay, divided by the probability, okay, okay, of getting a positive result, okay, okay. Now, this is sort of okay here. We've got most of the data that we require, okay. We have that the probability of positive, that an email being classified as positive, classified as spam when we actually give it spam, okay, is 0.90. So this is 0.90 times the probability of a spam email. We know that 3 emails in 100 are spam, so that's times 0.03, divided by this probability here, this probability of a positive detection. Okay. Now,